like the videos. If you have any information, please drop it at the comment section so that when I get time, I will attend to you. Alright, so now let's continue. The right-angled triangle, Pythagoras theorem. So we'll solve one example or two examples on application of Pythagoras theorem, then we'll end here. So let's be fast. Alright. So let's see this question. Alright, welcome back. The length of the side of an equilateral triangle is 12 centimeters. Find A, the height of the triangle. B, the area of the triangle. C, the perimeter of the triangle. Again, the length of the side of an equilateral triangle is 12 centimeters. Find A, the height of the triangle. Do you quite remember that I said what another name for the height can be what? Altitude, or the perpendicular what? Height. So altitude, height, or what you can refer to it as a perpendicular height. So A, the height of the triangle. B, the area of the triangle. C, the perimeter of the triangle. So now let's solve this question. Solution. So now the length of the side of an equilateral triangle is 12 centimeters. So I said when you get a question like this, it's an application question, right? So you have to what? You have to sketch something in order for you to get what? A mark for that. So please, let's sketch our equilateral triangle. What's an equilateral triangle? Equal sides, so equilateral, so equal sides. So it means that it's a plane figure or a plane shape with what? Equal sides, or all the sides, all the three sides are equal, or all the what lengths are what equal. That's what an equilateral triangle. Isosceles triangle, two of its sides are equal. So it means that the base angles to what? Equal. Then you come to scalene triangle. None of the sides are equal, or it has what? Unequal sides. Alright, so equilateral triangle. So the length of a side of an equilateral triangle is 12 centimeters. So I say equilateral triangle, it has what? All sides equal. So when you see one stroke, one stroke, one stroke, it means what? All the sides are what? Equal. If you see one stroke, one stroke, one stroke, all the sides are equal. If you see two strokes, two strokes, two strokes, all the sides are equal. But if you see one stroke, then two, it means this side and this side are what? Equal. So please take note of that. Take note of that. So now, So the length of the side is what? 12 centimeters. So it means that here is 12 centimeters, 12 centimeters, then here 12 centimeters. So now, we said we should find for what? The height of the triangle. That's the altitude. So the height of the triangle. So which is what? Perpendicular to the base of the triangle. So the height. So it's a line drawn from what? The apex or the vertex of this triangle to what? To the base of the what? Triangle. That's the altitude, or that's the perpendicular height, or that's the height or the actual height of the triangle. Alright, so let's see. So now we want to find for the altitude. So let me label here A, B, then what? C. So I can see that what? Considering triangle, let's see, triangle, let me label this point here to be D. So considering triangle DBC. So triangle DBC, we have it as that. So here is 90, then we have that. Here will be 12 centimeters. 9 point D, 9 point B, 9 point A. Please watch it very, very carefully. Watch it very carefully. Alright, so let's continue. So now let's see. From this point A to this point B is 12 centimeters. So now how can we determine the point from D towards B? Listen to it again. From point A to point B is 12 centimeters. That's the full length of the base, or the base length is what? 12 centimeters. That's the length of AB, or the magnitude of AB, or the modulus of AB, or the distance of AB. Now, how will you find for the point from this point D to point what? B, so that we can write it here? You know that this line is equal. They are all equal. So we are here. So now you have to ask yourself, is this line dividing the triangle into two equal parts? Yes, it is dividing the triangle into two equal parts. So now you ask yourself, how many lines of symmetry has what? An equilateral triangle. It has 3 lines of what? Symmetry. 3 lines of symmetry. Isosceles triangle has what? 1 line of what? Symmetry. Scalene triangle has what? 0 line of what? Symmetry. It has none. No line of symmetry. So now, an equilateral triangle, you have this. So there's the line of symmetry, 1 line of symmetry, 2 lines of symmetry, then what? 3 lines of what? Symmetry. So that's what? An equilateral triangle. Then now, let's see. So we have this 90. So if this line or this height from point D to point C, or from point C to point D, is dividing this triangle into 2 equal parts, then that means 2 divides 12 is what? 6. So it means that this distance is 6 centimeters. 6 centimeters. So how can we solve this question? You can solve this question by using what? Pythagoras theorem. By using Pythagoras theorem. So it means that I wanted to draw this theorem. So it means that in order for you to use what? A Pythagoras theorem to solve this, you have to know that, or we said that what? Pythagoras theorem states that what? The square on the hypotenuse equals what? The sum of the squares on the what? Other 2 sides. Again, the square on the hypotenuse is equal to what? The sum of what? Squares on the what? Other 2 sides, or the shorter what? Sides. So now AD and what BD are the two shorter sides. Then now how can you determine the what hypotenuse? Where the 90 degrees is opposite to what? To the side. Then that means that side will be what? Your hypotenuse. So this 90 degrees is opposite to what? To this side. So it means that what? This side from point A to point B is a what? Hypotenuse. Alright, let's continue. So it means that the length of AB all squared equals the length of AD all squared plus the length of BD all squared. So the length of AB all squared is 12 all squared, then equals the length of AD, that's the height. So let's denote it as what? H. So H squared plus 6 squared. So 12 squares give 144 equals H squared plus H squared give 36. So now we'll group like 10. So 144 minus 36 equals what? H squared. Right. So H squared equals, so let's see, 144 minus 36. So let's see. So now when you subtract 6 from 4, it can be possible. It gives us what? Negative. But we don't want a negative number. We rather want what? A positive number. So now we go right. We borrow 10 from what? This 40's column, right? Yeah, man. So it reduced to what? 3. So now here it becomes 10 plus 4, which is what? 14. 6 from 14. We get yes, help me. 6 from 14 will give you yes. Will give you yeah. Alright. So now let's see. Some of you are doing something that is okay. Now listen here. Pythagoras theorem is very, very simple, right? Very, very simple. So please learn it very, very well. Learn it very, 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 very well. Begging of you to learn it very, very, very well. It's very, very simple. So please don't say that the application is very, very difficult. Just understand the question. You say it to I believe you understand what I'm saying. Alright. So now when we subtract 6 from 14, we get what? 8. Because 8 plus 6 gives us what? 14. So we get 8 here. So now 3 from 3 gives us what? Gives us 0. Alright. Then here is 0, right? 0 from 1, we get what? 1. So here is 108. Right. So we what? We take the square root of what? Both sides. So square root here, square root there. So I'll get h equals square root of what? 108. 108 what? Centimeters. Since we don't have the square root of this, because to give us what? A set. That's an irrational number. Because this one we get it as what? A non-terminating decimal. So that's an irrational number. Alright. So now let's leave the height there. Okay, because we don't use calculator. But I taught you some trick on our last video. Let's see whether we recall. This one you can see that 10 times 10 times 10 is what? 100, right? Then 11 times 11 equals what? 121. So we can see that this 108 is in between what? 100 and what? 121, right? So now, watch here. How would you determine the decimal place? So when you see that square root of 108 is 11, then that means it's wrong. It must be between these. So that means this square root of 108 is approaching what? 11. Do you understand that? It is approaching 11. So it will be around 10.2. 10.234. Okay, so you can see that h will be what? 10 point, let's say 23 what? 23 what? Centimeters. So that will be what? The height in what? Decimal numbers. So you can use this analogy to get the height of that. Okay, alright. So that's that. So please watch it very carefully and understand the procedure used in solving this question. Thank you. Alright, so let's move on. We have another question. It said B, the area of the triangle. So now, let's see how we find for the area of the triangle. So this is my last example. My last example on application of Pythagoras theorem. So please, you can drop the homework, the assignment I gave you at the comment section, so that when I get time, I deliver to you. Alright, so now let's see. So B, we want to find for what? The area of the triangle. How do you find for the area of a triangle? Area of a triangle. So the area of a triangle is half times the base times the height. That's the perpendicular what? Height. So half times the base times what? The height. So it means that half times, you know, the base, which is what? 12 what? Centimeters. So that's the length of AB. Then times the height, which is the length of what? CD. Did you understand that? So half times length of AB is what? 12. Then times length of CD is what? Square root of 108. Right. So half times 12, or 2 goes here, 1 into 12 is what? 6. So I get 6 times square root of 108. Right. So 6 times square root of 108. This one you do it in what? SHS. That's SURDS. 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 S-U-R-D-S. SURDS. S-U-R-D-S. So now it means that when you get 6 times square root of 108, this square root of 108 has what? An invisible number, which is what? 1. So we take it as 6 times 1, then square root of 108. Right. So 6 times 1 gives what? 6, then square root of 108. What? So I have to leave my answer in what? Centimeters squared. So which is what? Talking of what? Area. Please, if you don't bring this, you deduct. Okay, so please be very, very careful. So that's the answer for what? The area of this triangle. Alright, so let's see the perimeter of the triangle. Let's see the perimeter of the triangle. The perimeter. How do you find for the perimeter of a triangle? Now, what then is a perimeter? When we talk of perimeter, perimeter refers to what? The total distance around what? A plane figure or a plane shape. That's the perimeter. So that's a perimeter. The definition of a perimeter, you are just going around the plane shape or the plane figure. So here, just going around the plane shape. So it means that the length of AC plus the length of what? AB plus the length of what? BC. So the length of AC is 12 centimeters plus the length of AB. The length of AC 12, then plus the length of AB 12 centimeters plus the length of BC, which is what? 12 centimeters. So 12 plus 12 plus 12. You can say that, let's say 3 times what? This 12 centimeters, which becomes what? 36 what? Centimeters. Not square, I'm begging of you. It's what? Centimeters. Because it's talking of what? Distance. Alright. Alright, so that's that. So let's move on to today's lesson on the right angled triangle. That's the Pythagoras theorem. Our last lesson on that. Now, when you take the Aquila textbook, he has treated more of what the right angled triangle. That's the Pythagoras theorem. He has treated tangents to an acute angle. We have what angles of what elevation, then what depression, right? Don't worry yourself. Don't worry yourself in learning that. When you go to SHS, you do more of that. You go into details. That one, you love it. You go into details of that. That's trigonometry, triangular what measurement, or triangle what measurement. You do that. So don't worry yourself in studying that. No, it's not part of your syllabus. So that's tangent of an acute angle, then that. But I'll talk briefly on that, then you know what is going on. But if you don't have time, we move on to our next topic. Alright. So now let's see. So today's subtopic, or the substrand, is Pythagorean triples. Pythagorean triples. You can just analyze the definition of this question. Just think about this. How will we explain Pythagorean triples? You can see something inside your memory. What is a Pythagorean triple? Now we know that triple is what? 3, right? Yeah, man. Triple is 3. So Pythagorean triples. Now, when you say Pythagorean triples, you are still dealing with what? Pythagoras theorem. So now watch here. So let's go. Pythagorean triples is a set of 3 integers which obeys the Pythagoras theorem. It's a set of 3 integers which obeys the Pythagoras theorem. So now, it's a set. I believe we know a set. A set is a collection of things of the same what kind. We have types of sets: finite set, infinite set, singleton set. We have power set. We have unit set. We have universal set, intersection of sets, unions. There are more of sets, right? So a set of 3 integers. You know 3, the number 3. This integers. Now, a symbol z. That's an integer. Now let's see what an integer is. An integer. Let's write something here. Now you see what an integer is. So now this explains what an integer. Set of integers. It means what? They are what? They are positive and what? Negative what? Natural numbers. Now let me clean. We because the negative is at what? The left hand side of the what? Of this 0. And the positive is at what? The right hand side of the 0 here. So now, integers are what? Negative natural numbers and what? Positive natural numbers, including 0. That's why we have this symbol union. So that means we are together. You know that a natural number, another name for a natural number is what? A counting number. So a counting number starts from 1, 2, 3, 4. Then it moves and moves and moves that, and so on and so forth. So that's what a natural number. Whole numbers start from 0, 1, 2, and they move on. So now, natural numbers, negative natural numbers, positive natural numbers, then we include 0. So if I have -5, -4, -2, -3, -2, -1, 0, 1, 2, 3, 4. So with this, I'm listing what? The set, or we are listing the set of what? Integers. So we can see what? Negative natural numbers, then what? Positive natural numbers, including this number 0. So please, 0 is an integer. 0 is an integer. 0 is an integer. Alright, so now that explains what? An integer. But here, if it obeys the Pythagoras theorem, then we don't like the negative here. We'll be talking or we'll be dealing with what? Positive what? Numbers here. Because Pythagoras deals with what? Distances or length or magnitude or what? Modulus. So it deals with what? Distances. So we don't like what? The positive what? We don't like the negative natural numbers, sorry. But we prefer what? The positive natural numbers, because we are talking of what? Distances. So now, let's go. So it's a set of 3 integers which obeys the Pythagoras theorem. So now let's see. You know that if I give you 3 integers and you want the integers, or you want to check, you want to show that whether these 3 integers obeys the Pythagoras theorem. You know that Pythagoras theorem states that the square on the hypotenuse equals the sum of squares on the other 2 sides. So the square on the hypotenuse equals the sum of squares on the other 2 sides, which obeys the Pythagoras theorem. So now, let's take any set of integers here. So if I have 3, 4, then I have 5. Let's see this. These are positive what? Natural numbers. So positive natural numbers. Now let's see whether this obeys what? The Pythagoras theorem. So if it obeys the Pythagoras theorem, then that means these integers, they are what? Pythagorean triples. Because they are what? 3 natural numbers here, positive natural numbers, to be precise here. So now let's see. Always take note that in the set of these integers here, or the set of these integers here, we have what? 5, the largest number, or the greatest number, or the highest number, or the biggest number, or the maximum number. The maximum value is what? 5. So it means that this 5 is always the length on the what? Hypotenuse. The 5, this 5 here, the biggest number or the highest number is always the hypotenuse, the length of that hypotenuse, or the longest on the side. And 3 and 4, you can place it anywhere, because that's what the distance of what the 2 shorter sides. So we assume that here is 3, then here is 4. So now, if you want to check whether this obeys the Pythagoras theorem, then you have to note that what? Pythagoras theorem states that what? The square on the hypotenuse equals what? The sum of squares on the other 2 sides. So now here, this is my hypotenuse, because this 90 degrees is opposite to what? This side here. So I have what? 5 squared equals 3 squared plus 4 squared. Right, so 5 squared gives us 5 times 5 equals 3 squared gives us 3 times 3, then plus 4 squared, 4 times 4. So now 5 times 5 is 25 equals 3 times 3, 9, plus 4 times 4, 16. So I have 25 equals 9 plus 6 here is 15, right? So 5 carry 1. 9 plus 1, 10. Plus 1, I'll get what? 11, right? So this one. Oh, it's not correct. Let's see. 9 plus 6, I'll get 9 plus 6 is 15. So 1 plus 2. 1 plus 1 is 2. Sorry. So 1 plus 2. 1 plus 1 is 2. Sorry. 1 plus 1. 1 plus 1 is 2. Alright. So now it's 25. So it means that 25 equals what? 25. The square on the hypotenuse here. And this two sides here. When you square this side, when you square this side, then you add your sum. You get what? 25. So it means that this is equal to that. So then that means this 3, 4, 5, they are Pythagorean what? Triples. Why? Because they obey what? The Pythagoras theorem. As simple as that. If a set of 3 integers obeys the Pythagoras theorem, then that set of 3 integers is what is a Pythagorean triples. Please, are you getting it? If you have 3 sets of integers and they obey what the Pythagoras what theorem, then that means that set of 3 integers are what Pythagorean triples. Alright, let's solve one and verify whether they are Pythagorean triples. Then I give you one to try so that we end it here. We don't move on to tangent. I'll talk something about it, then you know what is going on. You see that's that. So let's try this. 1, 0, 1, 2, 3. Let's see this one. So now we draw what? Our right angled what? Triangle. I always say that what? This 3 is the highest value, right? And it will be what? The length on the hypotenuse. Then here you can fix it here or there. It's the same thing. 1 or 2, 2 or 1 is the same thing. Because this addition is what? Commutative. Multiplication is commutative. So don't worry. So yeah, Pythagoras theorem states that what the square on the hypotenuse is equal to what the sum of squares on the other two sides. So I have 3 squared equals 2 squared plus 1 squared. So 3 squared gives us what? 9 equals 2 squares gives us what? 4. Then plus 1 squared 1. So here 9 is not equal to 4 plus 1 5. So 9 is not equal to 5. So it means that this is not a Pythagorean triples. They are not Pythagorean triples. It's not a Pythagorean triples. Why? Because it does not obey the Pythagoras theorem. It doesn't obey the Pythagoras theorem. So if you don't obey it, then you are off. You are off. You are not a Pythagorean triples. So you are off from that. Alright, so let me give you 1 or 2 examples to go and try, to go and verify whether they are Pythagorean triples. One, they said, go and try. So assignment for you. So they said, which of the following sets of numbers are Pythagorean triples. A 1, 2, 3. B 12, 30, 32. C 40, 75, 85. D 18, 24, 30. E 11, 21, 23. So that's the assignment. Alright, so let's proceed. We are done with Pythagorean triples and we are done with our topic, the right angled triangle. But I'll talk briefly on the tangent of an acute angle, then angles of elevation and depression. Do not set questions for you on that to subtopic, so you don't know. I just want to talk something about that. So now, let's see tangent of an acute angle. Tangent of an acute angle. Now, acute angle. We have this. We have theta here. Now, this is an acute angle. It's an acute angle. This is an acute angle. Why? Because this angle is greater than what? 0 degrees. That's the starting point of this. 0 degrees. Then it is less than what? 90 degrees. Yes, 90 degrees. So it is less than what? 90 degrees. So now, how can we so let's see something here. So if it is greater than 0 degrees, then that means the angle starts from what? 1 degrees, 2 degrees, 3 degrees, 4 degrees. Then it moves, then it ends at what? 89 degrees. Why? Because it is less than 90 degrees, but what? Greater than what? 0 degrees. So that's the definition for acute angle. So we have acute angled triangle. Alright. So now let's see. Tangent of an acute angle. We have the three trig ratios, but there are more of the trig ratios. When I mention them, you won't know what they are unless you go and meet them at the university, then SHS. Yeah. So please learn hard. So now we have three trig ratios. Three trig ratios. Trigonometry, triangle measurement. They are trig ratios because they are used to find for what? Angles. They can be used to find for angles of what? Of an acute angle here. Right. Acute angled triangle. They are trig ratios because you can use them to find for what? Distances or lengths. So they are very, very important in what? Triangle measurements. So now we have sine. So S-I-N-E, known as S-I-N. So sine, that's the short form for that. So I can say sine theta. Then we have cosine, which is cos theta. Then we have tangent, which is tan theta. Now we have, so these are the three trig ratios. That's the common ratio we know. Then when you go on, you get cotangent. That's the inverse of tan. So we can say cot theta. Then here we have secant. So that's sec theta. Then we have cosecant. That's cosec theta. When you go to the university, here when you go to SHS, you have to know all this. When you go to the university, they will mention some for you. That's cosh. That's cosine of what? Hyperbolic what? Function here. Cosine of hyperbolic function. Then we have sinh. That's sine of what? Hyperbolic function. Then we have tan of what? Hyperbolic functions. Then we have secant of what? Hyperbolic function. Cosec of what? Hyperbolic functions. So there are more of the what? Trig ratios. Alright, so now that's that. So when you hear we have some acronym or some funny thing we use to represent that. Don't let me say funny, but let me say we used to recall ourselves. So that's what Sokatwa, right? Sokatwa. That's, some of you've heard of it before. Sokatwa. That's so. When you hear so, that means it moves with what? Sine. Then ka, it moves with what? Cos. Then twa, it moves with what? Tan. So Sokatwa. So is what? Opposite on hypotenuse. Then ka, that's adjacent on what? Hypotenuse. Then tan, that's opposite on what? Adjacent. Opposite on adjacent. Now let me draw my right angle triangle. So 90. Now with here, without any angle inside the triangle here, there is no opposite. Now if I bring an angle inside here, then that means there will be what? An opposite. So where this angle, that's the unknown angle, but this one we know it, which is what? The 90 degrees. Where this 90 degrees face is what? The hypotenuse. Please don't forget. Or the longest side. So this unknown angle, where it faces or where it's what? Opposite to the side, then that means this side becomes what? The opposite. So where the unknown angle faces becomes what? Opposite. Then we have what? The hypotenuse. Then this side becomes what? Adjacent. Please, do you understand that? So take note. Where the unknown angle faces becomes what? Opposite. Then where the 90 degrees faces or the longest side, it becomes what? Hypotenuse. Then the rest becomes what? The other distance or the other length or side becomes adjacent. So please take note of that. So now that's what I can say about tangent of an acute angle. There are more. But we are in GHS theory and I don't want you to dive into it seriously. When you go to senior high level, they will teach you. Now concentrate on what we've discussed. It's very, very important. Don't forget. It's very, very important. So now let me talk of angles of elevation and depression. Angles of elevation and what? Depression. Now we have elevator. Elevate, to bring something up, right? To raise something. So angles of elevation, then depression. Angles of elevation and depression. Now, if you are depressed, then that means at first you were happy. So if you are depressed, you calm down. So now here, elevation. up, depression, down. Elevation, up, depression, down. Elevation, up, depression, down. Elevation, up, depression, down. So now let's see angles of elevation. Let's watch something here. This scenario. Now, you're on the horizontal ground. So let's see horizontal ground here. So that's we. I can't say me. I beg you. So that's we. So horizontal ground. Then we have a tree here, right? We have a tree here. So now we can get what? A bed on this tree, a bed on the tree, or several beds on the tree. Now this young man here wants to what? Point gun at one of these what? Beds, or of those beds here, right? So now this man won't look down. Why? Because he wants to what? Kill these birds. So why do you want to look down? You have to what? Look what? Up. So immediately this man raises up his head to look there, then that means we get what? An angle of what? Elevation here. Immediately this man, this young man raises up what? His head, we get what? An angle of elevation. Because at first the head was like this, that's straight, you are looking straight. But now you raise up your head, then that means we get what? An angle in between that. Please, do you understand that? So that's what? Angle of what? Elevation. That's the angle of elevation. So up, right? Then now, angle of depression. Now, when you are coming to point a gun at a bed on a tree, now the bed too has what? Sense. So the bed can look at you and say, hey, this man is very wicked. You want to kill me? No. So the bed will look you downwards, right? So below the tree, so the bed will look at you. Hey, this man is very, very wicked. Very, very, very wicked. You want to kill me for your soup? It will never happen in Jesus' name. Then you say what? Amen. So now, immediately the bed looks down. Down. Then the bed too has created what? An angle of the area. Depression. An angle of depression. An angle of depression. Right. So immediately this bed raises his head down. Or immediately this bed looks down. Sorry. It creates what? An angle of what? Depression. So it means that angle of elevation is equal to what? Angle of the area. Depression. Angle of what? Elevation equals what? Angle of what? Depression. Please take note. Why are they equal? We had it from what? Alternating what? Angles are what? Equal. Alternating angles are what? Equal. Because this one is looking straight, this one too straight. So we get what? Parallel what? Lines. Parallel lines are lines which what? Do not meet at a point, right? So now we can get what? Alternating angles are equal. That's why angles of elevation is equal to what? An angle of what? Depression. So now that's that. When you go to SHS, you solve questions on that, then you'll be cool with the angles of elevation and what? Depression. Alright, please do well to subscribe to Massa tutorials for more of the GHS mathematics videos. Alright, please do well to what? To solve more examples on what? Pythagoras theorem or the right angled triangle. I promise you, the math phobia they have been saying, or fear mathematics, it will never be your portion. So please learn and learn more. Get the feeling that I can pass mathematics. I will pass this BC mathematics. Sure, you will pass. You will pass. I love you saying amen. You will pass in Jesus' name. Amen. So now we meet again meet again on our next video. We'll meet on our next video. So when I come, I'll tell you the topic we'll treat. So please stay tuned and have a nice day. Bye bye.